Hi, we continue the 8.4 diagnostics, the unusual points. So if a few observations have very large residuals, the hut values and or Cook's distances, the estimation result is influenced too much by those observations, making estimation less reliable. So to detect extreme values for these statistics, the half normal QQ plot is useful, while the distribution is not expected normal. So just that we use half normal QQ plot to detect values which is much larger than the other observations. So we don't really expect the normal curve, but still the half normal QQ plot is useful to see how extreme some observations are. So there's several things. So this is the studentized residual, and this is influence, HI, and this is Cook's distance. And you can see how large some observations are. The studentized residual, the largest one is 13th observation of this Galapagos Island data. So this is about maybe the 9. So positive and negative residuals are put together because this is half normal QQ plot. But the second largest one is 7 and the third largest one 6. So 9 is not much larger than the others. So probably this data is good in terms of the studentized residuals, the no outliers. So there is no clear threshold, but the one have the residual of 20 and the others are less than 3. Certainly, that's a big problem. And the second, influence. The HI is largest one is 0.7, and the second largest one about 0.5 or 6, and the third one 0.5, and so on. Possibly this observation, 25th observation, is too large. It has too large HI, but probably not that extreme. Maybe we can check if what happens for this 25th observation. So Cook's distance measures how much influence each observation has on estimated parameter. And here again, the 27th observation and 25th observations have a little larger impact than other observations. So some other observations also have Cook's distance of maybe 1 or 2. So 3 point something is maybe not too large, but still maybe it's good to check if something is wrong with these observations. Yeah, so these plots are generated by this half normal function and these statistics, the functions to generate these statistics. Yeah, to generate 3 graphs in one window, you can specify 1 by 3 using parameter option MF row, multiple figures by row. Yeah, so this is basically the robustness check for the previous model for Galapagos Island data. So basically we exclude 25th observation. 25th observations. Then, so these are the estimates. And you can compare this with the previous output. And actually the first 3 and the last one is not much different, but this becomes smaller and less significant. Previously, all observations are significant, but here the distance to the Santa Cruz Island, this becomes less significant after we remove 25th observation. So only 25th observation makes this variable significant. So probably there is not a strong relationship between the number of species and the distance to Santa Cruz Island. Yeah, residual deviance improves a bit from 360 to 354. So 25th observation disturbs a bit to the model. And actually for this model, the observations, the variables that do not entirely explain the situation since the deviance is much larger than the degrees of freedom. So we introduce the over dispersion parameter, and actually this is the 16. This is much larger than 1. So if we use this dispersion parameter, standard errors are updated. So still, these variables are important and the significant, but here the distance to the nearest island actually does not matter. So possibly the best model is the number of species on intercept and log of area and log of distance to the, log of the area of adjacent island. Yeah, so this is one example on how to apply the diagnostic methods for data analysis. So if some extreme observations, maybe you can just exclude those observations and estimate the model again, then you can at least check the robustness of the model.